In this lesson, we're going to be talking about the four equations of linear motion. Linear motion has four main equations, and the first one is v equals u plus at. The second one is given as s equals ut plus half at squared. The third one is given as v squared equals u squared plus 2as. And the fourth one is given as s equals u plus v all over 2 multiplied by t. Now, each of these alphabets represents a particular physical quantity. V, for instance, represents the final velocity. U represents the initial velocity. A represents the acceleration. T represents time. And S represents the displacement of the particle or object in motion. All right, so these four equations are very important as long as linear motion is concerned. So now, how do we make use of these four equations to solve problems on linear motion? To solve problems on linear motion, there are three main points you must take into consideration anytime you're faced with a question. What are these three important points? We have number one, when an object starts from rest, the initial velocity is always equal to 0. And number two, when an object or a body decelerates uniformly to rest, or we can say comes to rest, the final velocity of that body is equal to 0. And then number three, when a body moves with constant or uniform velocity, the acceleration of that body is equal to 0. So to solve questions on linear motion, these are the three important key points we must have in mind. All right, so now we're going to look at an example here, and we'll see how to apply these points in solving problems on linear motion. Now the question here says a particle starts from rest. Remember, point one here says when an object starts from rest, initial velocity is 0. So since they said a particle starts from rest, we need to write it down that the initial velocity of that particle is 0. Whenever you're given a question and they say the particle starts from rest, initial velocity is 0. If it's coming to rest or it decelerates uniformly to rest, the final velocity, which is the ending velocity, is 0. If it's moving with constant or uniform velocity, acceleration is 0. So back to our question again, a particle starts from rest. This sentence here means the initial velocity of that particle is 0. And then they say, and it moves with constant acceleration of 0.5 meter per second squared. So they gave us the acceleration of that particle to be 0.5 meter per second squared. They said the distance covered by the particle, you're looking for distance covered by the particle in 10 seconds. So we're giving time to be 10 seconds. So we're looking for the distance covered by the particle in 10 seconds. All right, so how do we go about this question? It's very easy. Right here we have our four main equations of linear motion. So which of these equations do we use to solve? All we need to do here is go back to our formula. Which of these four formulas here has u, a, s, and t? If we look at the first formula here, do we have u present in this first formula? Yes, we do. Do we have a? Yes, we do. Do we have s? No, we don't. So because of that, we cannot use this formula. We go to the second formula. Do we have u present in this formula? Yes, we do. Do we have a present in this second formula? Yes, we do. A is here. Do we have s? S is also present in the formula. Do we have t? T is also present. So that means this is our formula to use. If we go to the third one, you see that the third one, do we have u in the third formula? Yes, we do. Do we have a? Yes, we have a. Do we have s? Yes, we have s. Do we have t? No, we don't. So because of that, we cannot use the third formula. If you try the fourth formula too, you see that in the third formula, yes, we have u in the third formula. We also have, do we have a? No, we don't have a in the fourth formula rather. All right. So if you look at this fourth formula, you don't have a in this fourth formula. So that means you cannot use this formula to solve. So the only formula we can use is the second formula here, which is s equals ut plus half at squared. So now all we need to do here is to plug in our values into that equation. S equals ut plus half at squared. Remember, we're looking for s, so we'll just say s will be equal to u is equal to 0 times t, which is 10, so we have 0 times 10 plus 1 over 2 times a, which is 0.5, all right, times t squared, which is 10 squared. So that's going to give us the displacement to be equal to 0 times 10, that will give us 0. So we have half times 0.5 times 10 squared, and that will give us 25 meters, which is option C. Now, our next question here says a car moving with a speed of 90 kilometers per hour. All right, speed in this case will be represented with the symbol for velocity. All right, because both speed and velocity have the same magnitude, but the only difference is that velocity has magnitude and direction, speed has only magnitude. But in this question, we are concerned about just the magnitude, so we don't bother about whether it's speed or velocity. We can actually call speed velocity. All right, so in this case, we can say since this is the first velocity mentioned in the question, a car is moving with this in the motion. All right, this is what we know. This is the first information about the velocity, so we can say this is our initial velocity to be 90 kilometer per hour. All right, they say was brought to rest. It was brought to rest. Okay, so it simply means final velocity equals 0 by the application of brakes in 10 seconds. So you have time to be equal to 10 seconds. They say how far did the car travel? So we're looking for distance after the brakes were applied. All right, so this is what we're looking for. This is what we want to solve. How far did the car travel after the brakes were applied? Now remember, we have four equations of linear motion. V equals u plus at, s equals ut plus half at squared. We also have v squared equals u squared plus 2as. We also have s equals u plus v all over 2 multiplied by t. All right, so which of these formulas are we going to use? All we need to do here is to ask ourselves, which formula here has all four of these? First one is not correct, the second one is not correct, the third one is not correct, the fourth one is the formula we're going to go with. Let's confirm. You look at what we have here. U, do we have U in this formula? Yes. All right. V, do we have it in this formula? Yes. Do we have T in this formula? Yes. Do we have S? Yes. So this is the formula to go with. All right, so at this point we just need to plug in our values and we'll get our answer. So we're going with s equals u plus v all over 2 multiplied by t. Now if you observe, u is 90 kilometers per hour, v is 0. All right, and time is in seconds. Here you have time in hour, here you have it in seconds, so you must convert from kilometer per hour to meter per second. If you observe also, virtually all the options are in meters. So let's put our answer, our velocity here, initial velocity, to be meter per second. Let's convert it to the standard unit. Now 90 kilometer per hour, to convert to meter per second, all you need to do is multiply by 1000 and divide by 3600. So we're going to have 90 times 1000 divided by 3600. And that's going to give us 25 meter per second. So at this point, we simply plug in our values. We now have s equals u is 25 plus 0 all over 2 times t, which is 10. And that's going to give us 125 meters, which is option A. Now the next question here says a motor vehicle is brought to rest. It is brought to rest. It simply means final velocity is 0 from a speed of 15 meter per second. So from an initial speed of 15 meter per second in 20 seconds. Time is 20 seconds. It's a calculate the retardation. All right, so we're looking for the retardation. Retardation is a form of acceleration. It's a negative acceleration. So by the time we finish solving here, we see that our answer here will be negative. Okay, so which formula are we using? Again, we have four formulas for linear motion. V equals u plus at, s equals ut plus half at squared, v squared equals u squared plus 2as, and then s equals u plus v all over 2 times t. All right, so which one of these are we going with? Is it the first? Is it the second? Is it the third? Is it the fourth? So let's look at the first formula. Does the first formula has V? Yes. Does it have U? Yes, it does. Does it have T? It has also. Does it have A? Yes. So that means we're going with the first formula here. So come down here, we'll say using V equals U plus AT. All right, we are looking for A, so we have V to be 0, U is 15, plus A is unknown times T, which is 20. So we have A times 20, that will give us 20A. All right, this is positive 15, so say plus 15 equals 0. So we are looking for A. We move 15 to this other side of the equation, and then that's going to give us 20A equals minus 15. So to get A, we divide both sides by 20. So we have 20A all over 20 equals minus 15 all over 20. If we divide, that will give us A to be equal to minus 15 divided by 20. That will give us minus 0.5 meter per second. So this is our answer. The acceleration is retardation, which is negative acceleration. So we can also write it this way. Negative acceleration, which is retardation, to be equal to 0.75 meter per second. And that meter per second squared rather. All right, this is meter per second squared. .75 meter per second squared. Okay, so this is our answer here, option A. Okay, at this point, we've come to the end of this video. If this video was helpful to you, please drop a comment and also share to your friends and your colleagues. Do not forget to subscribe. See you in the next video.